So let's talk about simplifying logarithms. Now, before we go over some examples involving simplifying logarithms, there are some few things you need to be familiar with. Let's begin with the first one. If you have a log of a certain value, let's say y, to a base of x, such that y is with an index z, this is simply equals to z multiplied by log of y to a base of x. Just keep that in mind. Now, what if instead of having y to be with an index, what if it is x we are having that's with an index? What will that becomes? If you have a log of certain value y to the base of x such that x with an index z, in this case, this is simply equals to 1 over z, then multiply by log of x to a base of y. Okay, now the next one is if you have a log of y to a base of x such that you are having a value to be multiplying y. In this case, this is simply equals to log of y to a base of x plus log of z to a base of x. Now, what if instead of having a value to be multiplying y, we have it to be dividing y? In this case, this will be equals to log of y to a base of x minus log of z to a base of x. And the last thing you need to know is whenever you have a log of a certain value y to a base of same value y, this is simply equals to 1. So log of any value to the base of same value is simply equals to 1. Now, let's try to go over some few examples. Let's begin with the first one. By the way, feel free to pause the video and try to provide the solution to this problem. Simplify the log of 27 to a base of 3 plus 2 log of 9 to a base of 3 minus log of 54 to a base of 3. Now, one thing I'm going to share with you that you need to make sure that it works with is whenever you have to simplify logarithms, values without using calculator, the first thing you want to consider doing is to check for the least value you have in that problem, regardless of what it is, either the base or the value. You just want to check for the least number, the least value you have in that problem. Now, in this case, the least value we have that we can't simplify to the lowest term anymore is actually 3. So our goal is to re-express all these logarithms to a situation whereby we will end up having something like this: log of 3 to the base of 3, such that it should now be equals to 1. If we can't actually re-express any of this as this, then our answer is allowed to leave as it is. I hope you get my point now. So let's begin. Now, in how many different ways can we multiply 3 by itself that will result in 27? So it turns out that 3 times 3 times 3 will be equals to 27. And in index form, 3 to the power of 3, which is same as 3 cubed, will be equals to 27. Now, what about 9? It turns out that 3 in 2 places will simply be equals to 9. And in index form, 3 squared will simply be equals to 9. But you notice that 54, there's no way we can keep on multiplying 3 by itself, and later on we are going to end up having 54. It is actually impossible. So for a problem like this, there's something you need to do. But before we go into that, let's try to deal with the ones we have first. Okay? Hopefully you are following. So our next goal is to replace 3 cubed with 27 and 3 squared with 9 wherever we see 27 and 9 in the expression. So we have the log of this 3 to 3 cubed plus 2 log of this 3 to 3 squared, then minus log of this 3 to 54. That's exactly how that one is. So we leave it as how it is. The next thing is to bring this to the front. Likewise this. I said it earlier that whenever the value is with an index, you are allowed to bring it to the front of the logarithms. Okay, good. So this will become 3 times log of this 3 to a base of 3 plus 2 times 2 multiply by log of 3 to the base of 3 minus log of 54 to the base of 3. So this and this, which turns out to be equals to 1. You know, I said this earlier that whenever you add a log of a certain value to the base of same value, that's simply equals to 1. So we have 3 times 1 plus 2 times 2 times 1 and minus log of 54 to the base of 3. Good. Hopefully you are waiting this because I actually need to get rid of some stops over here. Okay. Good. So 3 times 1 in this case turns out to be 3. And 2 times 2 times 1 turns out to be equals to 4. Minus log of the base of 3 to 54. Now what should we do at this case? Let's try to sum. Oops, sorry, that's actually mistakes. Okay. So let's try to sum let's try to sum 3 and 4 together, and that's simply equal to 7. So left over we have 7 minus log of 3 to the base of log of 54 to the base of 3. Now back to this. Let's try to process this into some pairs, because there's actually a way we can actually do that. Okay, whenever you observe that you can't really multiply some certain number with itself, such that you will later end up having the value that is your target, the first thing you want to do in that case is to find a way to express that value as a product of two numbers, so that out of those two numbers you can actually express one as a product of the value you want to make use of. What I'm saying in essence is that we need to express 54 as a product of two values. Now notice that 54 can be expressed as a product of two values in different ways. You can have 27 multiplied by 2. This will result in 54. At the same time, 9 times 6 will also be equals to 54. And also 3 times 18 is also equals to 54. So we are having three different ways in which we can express 54 as a product of two numbers. However, we still have much more ways in which we can do that. But let's focus on these three alone. So out of these three, we still need to make use of one. Which of these three options should we make use of? Whenever you comes to, or we arrive at a situation like this, you want to make use of the one that will be the best one to make use of, as you want to make use of the one that won't stress you more. Okay, that after making use of it, you won't have to simplify it to the lowest term again. What I'm saying in essence is that if we make use of this, we're going to simplify 3, likewise 18. If we make use of this, we're going to simplify 9, likewise 6. But if we make use of this, we're going to simplify 27 alone, as there's no way we can simplify 2 anymore, because 2 as turns out to be the least value we can have in that case. So in that, whenever you come across problem like that, you just want to make use of the one that will be the best one to use, as the one that won't stress you anymore. Okay, so let's try to make use of 27 and 2. So the next thing we want to do is to replace 54 with 27 and 2. So we have 7 minus log of the base of 3 to 27 times 2. Okay, now at this point, we're going to apply one of the identity we discussed right from the beginning of this video. It says that whenever you are having two different values multiplying themselves, they can be equals to this. So I'm going to write it over here. Let me use different color to make it recognizable. So we have 7 minus log of the base of 3. So we just need to distribute the log of the base of 3 respectively. Then that's 27 divided. So we have 27. Then the positive side, log of the base of 3 to 2. Now at this point, you just wanna you just wanna simplify log of 3 to a bit to 27. Now earlier in this problem we said log of 27 to the base of 3 is simply equals to 3. For the sake of those who might be wondering how come, if you are following, you should know that it's equals to 3. You know that 3 cubed is the same as 27. So we just want to replace 27 with 3 cubed plus log of base of 3 to 2. Okay, so this is allowed to come to the front, and we have 7 minus 3 times log of 3 to 3 plus log of base of 3 to 2. And at this point, you can actually turn log of base of 3 to 3 to be indeed equals to 1. Okay, So our final answer in this case is 7 minus 3 times 1 and plus log of a base of 3 2. So 7 minus 3 plus log of a base of 3 to 2. 7 minus 3 is simply 4. So final answer in this case is 4 plus log of a base of 3 to 2. So that is the final solution to this problem. Round 2. Simplify the log of 13.5 to a base of 3 minus log of 10.5 to a base of 3. Whenever you are having a decimal values, the first you want to do is convert them into a whole number or a fraction. And to do that, you need to mix up some things. Now let me show you one thing. Whenever you want to express a decimal value, let's say 0.01 into a fraction, all you need to do is to shift the decimal until you have a whole number. When I shift the decimal 1 unit to the right, I'm going to have 0.1, which is still the decimal value. But when I shift it 1 more unit to the right, I'm going to have 1, and 1 is a whole number. So in that case, 0.01 in fraction is 1 over how many units? 2 units. That's 100. Okay, what if it is 0.12? That's if I shift it to 1 unit, that's 1.2. So 1 more unit, that's 12. That's simply 12 over 100. Okay, so that's exactly how to convert a decimal value into a fraction. So we're going to be making use of this concept to convert 13.5 and 10.5 into a fraction. So now let's begin. So for 13.5 in fraction, that's simply equals to, if we shift it to 1 unit to the right, we have 135 over 10. You know, it's just 1 unit. Then 10.5. If we shift it 1 unit to the right, we have 105 over 10. It has also 1 unit to the right. Now the next we want to do is to replace 10.5 with 105 over 10, and 13.5 with 135 over 10, and boom, we are good to go. So let's do that. So we have log of a base of 3, so 135 over 10, the minus log of a base of 3 to 105 over 10. Now at this point, we want to apply some of the identity we made mention of right from the beginning of this video. We said whenever we are having two different logs with the same base to be subtracting each other, we can just divide their values with each other. So this is simply equals to log of the base of 3 to 135 divided by 10, then all divided by 105 over 10. Okay, and this can also be expressed as a log of base of 3. So at this point, we can just apply the concept of keep, change, and flip. We just need to keep the first fraction 135 over 10, change the division sign to multiplication, and flip the numerator and the denominator of the second fraction. That's 10 over 105. Okay, at this point, 10 can cancel. When 10 cancels, let's try to split 135 and 105 into the lowest term. So what should we make use of? Let's make use of 15. In how many different ways can 15 go in 135? So let me make use of my calculator at this point. So that's 9. What about 105? In how many different ways can 15 go in 105? That's 105 over 15. That's 7. Good. Now left over we have let me get rid of this first. Okay. We have the log of a base of 3, so 9 over 7. Good. Now we need to apply the same identity because this can be done in a vice versa manner. Okay, if you're having two different log values to be subtracting themselves, you can turn into division. If you have two different values to be dividing themselves, you can turn into subtraction. You can just do it in a vice versa way. So this is typically equals to log of a base of 3 to 9, and minus log of a base of 3 to 7. Now earlier in this video we said log of a base of 3 to 9 is simply equals to 2. But for the sake of those who might be wondering how is equals to 2, I'm gonna show it out. Okay, you just want to multiply 3 by itself to result in 9. That's simply 3 squared equals to 9. So when I replace 9 with 3 squared, and boom, we're gonna get our final answer. Okay, so we have log of the base of 3 squared minus log of the base of 3 to 7. Now this 2 is allowed to come to the front of the logarithm, and left over we have log, sorry, that's 2 times log of the base of 3 to 3 minus log of the base of 3 to 7. Alright, now at this point, log of the base of 3 to 3 turns out to be in the equals to 1. Okay, so we have 2 times 1, that's 2 times 1, and minus log of the base of 3 to 7. So final answer in this case is 2 minus log of the base of 3 to 7. Now you are now familiar with how to simplify logarithm functions. Okay, now try to pause the video and try to provide a solution to this last problem. Good. Now round 3. Simplify log of 3 to the base of 9 plus log of 27 to the base of 3 minus log of 81 to the base of 27. Now, like I said earlier, I made mention of something. I said whenever you have to simplify a logarithm functions or values without using a calculator, you just want to figure out the least value you are having in that expression. So the least value in this problem is what? Exactly 3. So we just need to simplify these values or this logarithm expression by turning whatever bigger value we have into the numbers, so that when we multiply 3 with itself, we're going to result in that number. Okay, so what should we do in this case? Let's begin with 9. 3 in 2 places, we said is simply equals to 9, and in index form 3 squared is equals to 9. So what about 27? We said 3 in 3 places is indeed equals to 27, and in index form 3 cubed is equals to 27. Now what about 81? 3 in 4 places turns out to be equals to 81. In index form 3 to the power 4 is indeed equals to 81. Now keep in mind, whenever you have something like square root of a, this is typically equals to a to the power of half. Alright, so definitely square root of 3 in this problem is the same as 3 to the power of half. Just keep in mind, as we're going to replace square root of 3 with that. So our goal, just like before, let's replace each and every value we have here with whatever we have them as an index. So we have log of 3 to the base of 3 squared plus log of 3 to the power of half to 3 to the power of 3 minus log of 3 to the power of 4 to 3 to the power of 3. Now, just like before, we are allowed to bring this to the front. Likewise this, and this is the same as 3 to the power of 1. We can bring it to the front as well. So let's do that. So we have 1 times log of 3 to the base of 3 squared plus 3 times log of 3 to the base of 3 to the power of half, and minus 4 times log of 3 to the base of 3 cubed. Now at this point, we still need to bring some values to the front of the logarithm values. So typically the index of the base. Now, if you could recall, I said whenever the index of the base is coming to the front of the logarithms, it's going to turn to a reciprocal, okay, and not a whole number. But whenever the index of the value or the function is coming to the front of the logarithm values or expression, it's going to turn to be a whole number to multiply that. So we're going to have 1 times, when this is coming to the front, it's going to become 1 over 2 and not 2. 1 over 2 because it's an index of the base. So log of 3 to the base of 3 plus 3 times, when this half is come to the front, it's going to become 1 over 1 half. So times 1 over half multiplied by log of 3 to the base of 3 and minus 4 times, when this is coming to the front, it becomes 1 over 3 and multiplied by log of 3 to the base of 3. Now at this point, we just need to turn log of 3 to the base of 3 to be indeed equals to 1. So we have 1 times 1 over 2 multiplied by 1 plus 3 times 1 over 1 over 2 multiplied by 1 minus 4 times 1 over 3 multiplied by 1. Okay, now that just multiply everything. So to this part, everything returns out to be equals to 1. 1 times 1 half times 1. That's 1 over 2 plus, what about this part? 3 times 1 over 1 over 2 times 1. So what will that becomes? Let's try to simplify the middle term. So that simply works. Let me make sure this part. We are having 1 divided by 1 over 2. So let's apply the concept of keep change and flip. So 1 times 2 over 1 is simply equals to 2. So we have 2 at this point. So we have 3 times 2 times 1, that's simply equals to 6. Alright, so what about this part? Minus 4 times 4, 1 over 3, that's 4 over 3. Good. So at this point, we just need to find the LCM and solve for the final answer. Good. Now we're having 1 over 2 plus 6 over 1 and minus 4 over 3. So what should be our LCM at this point? We make use of 6 as the LCM. Okay, so if we make use of 6, we have 2 in 6, that's simply 3. 3 times 1 is 3, plus 1 is 6. 6 times 6 is simply 36, and minus 3 in 6 is 2. 2 times 4 is simply 8. So at this point, we can just sum all this up. So 3 plus 36 is 39, then minus 8 over 6. 39 minus 8 is simply 31 over 6. Final answer in this case is 31 over 6. Hopefully you now know how to simplify logarithm functions. Please, if you haven't subscribed to the channel, try to do that now. And also, don't forget to give this video a thumbs up, because that's exactly what it tells you to that this video is liked, so that you can refer it to many of the audience on your platform. Thanks for watching. I really appreciate it. See you guys in the next video.